Okay, so we're looking at quadratic equations. Quadratic equations, again, are anything that has an x squared term in them. Quadratics are going to be useful for us. They're going to be one of the most important parts of Algebra 2. One, because they take up a good chunk of it, but also they're really everyday applications. So now, you may not be taking trajectories of cannonballs and things like that. But this is an application that has to do with military. This has to do with a lot of different things. You have to know where things are going to land before they do. Otherwise, you get civilian casualties and stuff. So that's where a lot of this math actually came from, was from military background. Trajectories being one of them. With gravity, the pull on that is going to actually lend itself to parabola. What goes up is going to come down at the same rate of speed. So that's going to be important to know when it gets back down to 0 from the point it launched at. So we have a trajectory right here of a cannonball problem, which you guys should have done in the last section. There was also a problem about arches. When we look at arches, arches are going to actually be more structurally sound than the square frame. So this is going to normally be what you would see for a door. That's because it's cheaper. But a frame with an arch on it is going to actually be stronger structurally, and I think it looks a little bit better. So it's important to be able to know how far you're going to have to span across the doorway, things like that. So those are just some of the uses we have for quadratics. But whenever we look at the quadratics, it's important to know the solutions to these. That's going to be the roots. If you know the roots on these and the vertex, you're going to be able to graph your parabolas. What we're going to look at is just the roots of a quadratic equation, which are going to just be these points located right here, where it goes through the x-axis. So where it goes through the x-axis are going to be my roots. So we have a quadratic equation right here, x squared plus x minus 6. We want to graph this equation, which they've already done for us in this case. And then what we're going to do is we are just looking for its solutions. This is going to be what this section is going to look at. So we can do these, a lot of the times you're going to fall in between -2 and -3, where in this case it actually lands on -3. So we're going to normally just get an estimate by graphing. The first one we're going to look at is going to have exact values. The second one we're going to look at is going to have decimals. So you just kind of guess. Does it look like it goes through half, 3/4? But we can also put the graphs onto the calculator. The calculator will give us an exact answer, and we will be able to see how to do those on there as well. So if it ever tells you to do it by graphing, I don't care if you do it by hand or on the calculator. On the ACT, you can use a calculator, and anytime you're going to actually have to solve a quadratic, I'm sure you'd have access to a calculator. You're not going to be sitting in your bedroom one day and be like, oh, I need to figure out a quadratic. So anytime you do this in an actual application, you would also have it. So doing this on a calculator works as well. So on this one right here, they've already had it graphed, but again, we're just looking at the 2 points where it goes through the x-axis. So the x-axis crosses it twice, and then those are going to be my 2 solutions. So with a quadratic, I'm going to normally have 2 solutions. Now I could have one and I could have none. We're going to look at that later. If it's one solution, that means my vertex is on the x-axis. If there's no solution, that means that it would have a shape like it would go down this way. So this one doesn't go through the x-axis at all, so that would have no solution. We'd also have up here, could look like this, that would have no solution. So normally though, it's going to have 2 solutions. It's going to go through the x-axis twice. First one we're going to look at is going to be on page 11. Yep, page 11. I'm going to do number 6 here. So this is going to have exact values on the first one. The second page that you guys are going to have, page 12, those are going to just be estimates. So you're going to label the integers that it comes in between. So when I do this one, I keep in mind that it's going to have whole ones. So when I make my t-table, I have x and I have a y. It's easy to identify x is 0. That's just my c value. The other one I want to find is vertex. It's important to remember the vertex formula is -b over 2a. So I have an a value of 4, I have a b value of 4. So I have -4 over 2 times 4, which equals -4 over 8, which I can reduce down to -1/2. So now I want to evaluate this at -1/2. I'll have 4 times negative 1/2 squared plus 4 times 1/2 plus 1. Oops. So that doesn't equal 0. We'll see what it equals here in just a second. Okay, so we have negative 1 squared is negative 1/4 times 4 is just going to leave me with, this will be positive 1. So I'll have positive 1 plus 4 times 1/2 is going to be 2 plus 1. That equals 4. So at negative 1/2 my y value is going to be 4. So I can go through and I can put that in. So negative 1/2 y value of 4. At 0 I have a 1 value. So those are the two I have so far. So I have 1 to the right of my vertex. I want to get 1 more to the right. I also want to get 2 to the left to get the best looking U that I can get. So let's try negative 1, positive 1, and negative 2. So negative 1 squared is going to be 1. Still have my 4 out there, plus 4 times a negative 1 is a minus 4, plus 1. So 4 minus 4 is 0, plus 1 is equal to 1. So now I have 1 squared, which is just 1, times 4. Now I have 4 times 1, which is just 4, plus 1, which is 9. Plug in negative 2. I get a negative 2 squared is 4 times 4. Then we have plus, I have negative 2 times 4 is negative 8, plus 1. So I got 16 minus 8 plus 1 equals 9. So I have negative 2 and 9. I have 1 and 9. I also have negative 1 and 1. Alright, so I did 2 problems here wrong. I'm guessing the negative 2 and the 1. Let's take a look at this. We got negative 2 squared is a positive 4 times 4 is 16 plus a negative 8 plus 1. And that does come out to be 9. So now let's check my bottom ones. I know the 0, 1 is correct. So my vertex must be wrong. So at negative 1/2, I have negative 1 squared is 1, 2 is 4. So on this term it becomes positive 1 over 4, which gives me a value of 1, minus 4. Yeah. So I messed up on my vertex. This should be a negative right here, so I get a negative 2. So I get 1 minus 2 plus 1, which gives me a value of 0. Sorry about that, guys. Alright, so we find that that's 0 right there, so I have to change the position of my vertex. Otherwise I would have had a W instead of a U. That gives me a value right there. So now I'm going to go through, I'm going to make my U on this shape. Miss that last out a little bit. But what we're looking at here is we're looking for this spot down here. Where does it cross the x-axis? Now in this case it doesn't actually cross the x-axis, but it hits the x-axis and then turns around and goes back up. So I do go through the x-axis at -1/2, which is my vertex, but it's going to also be a root for this problem. But because I only go through once, I only have one solution here. So on this problem, -1/2 is my only solution because that's what my vertex is at. Alright, so let's try to go through this one a little bit smoother than we did the last one. We want to start off the same process though. We want to start off t-table, x and y. So when I plug a 0 in, 0 squared plus 6 times 0, I'm left with just the 6. So when x equals 0, y equals 6. Second one I want to look at is the vertex, which formula on that again is -b over 2a. So I'm going to go through and take my b value of 6. My a value here is just 1, so it's 2. That gives me a vertex. My x is -3. So I'm going to evaluate this. -3 squared plus 6 times -3 plus 6. That equals 9 minus 18 plus 6. That gives me a value of -9 plus 6 is -3. So far I have 2 points. One is 0, 6. It doesn't fit on here the way they've set this up, so I'm going to end up needing to count by 2's again. So it's 2, 4, 6. That's my y-intercept. Now my vertex is at -3, which will be halfway here because I'm counting by 2's, and then halfway here. So I have a vertex down here and I have 1 point up here. So now I want to just find 2 to the left of the vertex and 1 to the right because I already have it. So I'm going to try -4 and -5. I'm going to also go 1 to the right and I'm going to try -2. No, let's try -1. So I want to just plug all these values in, evaluate in this situation, and then graph this. So I have -4 squared is 16. Plus a 6 times a -4 is -24 plus 6. -5 squared is 25. Plus a 6 times a -5 is going to be a -30. And then plus 6 on this one as well. So the plus 6 always follows. -1 squared is 1. Plus 6 times a -1 is a -6 plus 6. So now I have my 5 points. I can go through and graph this, try to find out what my solutions are. 16 minus 24 gives me a -8. Plus 6 gives me a -2. 25 minus 30 is -5. Plus 6 gives me a +1. And then 1 minus 6 is -5. Plus 6 is 1. So here are my 5 values. I'm going to put these dots in. So the first one is -4, -2. So remember I was counting by 2, so -2, -4, and now -2 gives me a value right here. The next value is going to be -5, so that's in the middle, and that value is going to be a +1. So I'm going to cross somewhere in between -4 and -5. It's going to go through right in about here. That's going to be somewhere in between -4 and -5. Last point is -1. Remember I was counting by 2, so it's going to be right here. And that's going to have a +1 as well. So its reflection is the -5. So now I'm going to go through and try to graph these. This problem, I don't have exact solutions. Like, it doesn't look like it goes through -2 or -3, so I'm going to just be estimating on these. So I can go through and I can do these on the calculator. They'll give me exact values. So if you guys give me exact values, that's okay. But on this one, what we're going to actually do is we're just going to label this as one of my roots is going to be in between -4 and -5. The second root is going to be in between -2 and -1. So I'm just going to identify that it's in between -4 and -5, and in between -2 and -1. So that's all we have to do here. You guys can give me an estimate. Like, if I look at this, it looks like it's a lot closer to -5 than -4. So -4 is right here. It goes through, and -5 is up here, but it looks like it crosses a lot closer. So you could call this, you can just guess on these and do -4.75. The -2, the -1, it looks like it's closer to the -2, but barely. So I might call that one -1.75. So it's closer to -2 than -1. So you guys can give me points like this. You can give me the exact answer off of the calculator. Any of those are fine. But you could also just say that it's in between the two numbers. This would be the notation for that when we go through and do that. So you could also write it out as it's in between -4 and -5. Those are all options here. We're just on the ones where it doesn't look like it goes through -2, -4, we're just going to guess on those. So it's just going to be an estimate. We don't need exact answer there.